Good morning children. Welcome to today's science class. So in the previous class you all remember we learnt about the magnetic effect of electric current. Yes, no children? And also we did an activity to prove that magnetic effect of electric current. Do you remember that activity? We took a cell, we connected through a switch and we kept a compass needle inside a tray, and then when the circuit was complete, above the tray it was wound with a copper wire, and when the circuit was complete you are seeing the current flowing, and the magnetic effect was seen as the deflection in the compass needle. Yes, no children, do you remember that activity? So now we are learning about the magnetic effect of electric current. Previously we learnt about the heating effect, and we also discussed about the appliances which are using the heating effect, and also about the safety device which we use, which is working on the principle of heating effect, that is the fuse. Then now we are moving on further to the magnetic effect of electric current. Now today also we'll start the class with a simple activity. Yes children, now let us take an iron nail. So we will take a iron nail, children. So iron nail is taken, and above the iron nail we will wound with, wounding means winding with the copper wire, insulated copper wire. Insulated copper wire, by now you all know, I had shown you also. So now an iron nail is taken. Iron nail, here it is the copper wire. Copper wire we have wound it tightly, we have wound it, and now this three ends, two ends now. So through a key, that is through a switch, we will connect it to a cell. We will connect it to we can take a cell or we can take a battery also. Both can be taken. So this is the positive and negative terminals are there. So now this is our circuit. This is our simple circuit in which we have an iron nail wound with copper wire and a switch, and also a battery or cell can be taken. Now after every connection is given, always when we will call a circuit as complete circuit when everywhere connection is given properly and when the current is flowing. So now it is an incomplete circuit, or other words we can call it as an open circuit. You all know that. Now I will make it as a closed circuit. Closed circuit. Now switch is on, children. So now you all know that the current will start flowing through the copper wire. So current will start flowing through the copper wire. By this time we will bring some iron nails. Iron fillings are iron fillings. Pieces of iron, or we can take some iron clips also. These small iron clips also can be taken. Now you will see that once the current starts flowing, this iron fillings will start sticking to the iron nail. So what has happened to the iron nail now? So once the current was given to the circuit, what happened now? The copper wire is wound on the iron nail. It will, you know that the current carrying wire will start behaving like a magnet. So once once it has become the magnet, it starts attracting the iron fillings. This is one proof that when the current is made to pass through the conducting wire can behave as an magnet. Now we have created a magnet. This is one of the temporary magnet. So these type of magnet which we have made by passing the electric current are called as the electromagnet. This is our topic which we are going to learn today. So last year you have learnt about the temporary and permanent magnets, right? So permanent magnets are always, they behave like magnet. Now here we have made a temporary magnet by wounding the copper wire on an iron nail. As we know that due to the magnetic effect of electric current, once current is passing through this through the circuit, this copper wire will behave as a magnet. That will be shown that iron nails will pulling the iron fillings or clips. One of the how the magnetism can be proved. Due to magnetic effect, it is pulling. Now once you switch off, once you put the switch off, you will see that iron fillings are they will get detached and they will fall down as soon as the circuit is incomplete and it is becoming open circuit. When the current is not supplied to the copper wire, it will loses its magnetism, and that can be seen as the iron fillings are falling down. So such type of magnets are called as electromagnets. Why? Because they will behave magnet only when electric current is made to pass through them. So such types of magnets are useful also in our life. That's what we are going to learn now. Now again we can prove this. Once again we can prove that how is this acting as a magnet by bringing one bar magnet. Now you see the circuit is closed. Circuit is closed, and once the circuit is closed, you know that from the positive to negative the current will start flowing. Once the current starts flowing, the copper wire will act as a magnet that will be seen when the iron fillings are brought near the nail. The nail was attractive because that complete setup has become a electromagnet now. Now we will bring one bar magnet, children. You bring a bar magnet near to this iron nail. Now you will see that once you bring this sometimes it will be if suppose they both are having, this is our magnet now, no, this is acting as a magnet, this is also having two poles. Now that will be shown as a attraction or a repulsion. If suppose you are bringing, when it is getting attracted, that is attracted like this, it is getting attracted, you can see that there are the like poles are there. Now what you should do, you should change here. When you change this cell connection from other direction, the current will flow in the other way, then you can see it will be repelling. So the repulsion will be seen. Or else you turn the magnet and if you keep, then also you can see was attracting and repulsion. That is also one type of proof. One way we can prove that this setup is acting as this complete setup. What is the setup? Iron nail wound with the copper, insulated copper wire, which is the electromagnet here. This is the switch, we all know that. This is the battery, we all know that. These are the connecting wires. So which is acting as electromagnet now? The iron nail wound with the insulated wire is acting as the electromagnet. How long? Till you supply as long as we are giving the electric current, it will act as a magnet. Once the switch is open, it will not attract the bar magnet you bring, or it will not attract the iron fillings, or it will not attract any pin or anything you keep near that. So such type of magnets are called as electromagnets. So these electromagnets will play. We use them in our everyday life. We can see that. So where we are using electric motors, electric bell work, we will have an electromagnet. Also some of the toys which you used when you are a very small child, in that also some electromagnets will be there. But electromagnets even in the junkyard and all, junkyards where they will separate the iron garbage separately, there also they will use the cranes with the iron with the electromagnet. See children, now cranes, you all know that cranes are used to carry heavy metallic things like iron or nickel or copper, like car and all. You see many they will carry and they will keep in the another place. So in such type of purposes, it is very difficult to keep manpower to keep carrying here and there. So in such situations, crane with electromagnets are used. How they are used? One is the crane. For example, the crane is having the huge electromagnet like this. This is the crane which is having a huge electromagnet. So the control will be with the driver. Once he supplies the switch on, this will act as a magnet. And down, for example, a car is carried. Car or any heavy thing is carried. And after carrying, you have to keep it in another place. So now, again, if it is a permanent magnet, pulling it from that also needs lot of energy. So we cannot use the permanent magnets. Now what they will do, just they will put off the switch. So once the switch is put off, you know that this will not act as a magnet, and it will act as just a piece of iron. And the things, a car or any other heavy things which has to be carried from one place to another place, can be easily placed down. In such type of situations, electromagnets are used. For some time, temporarily they will act as a magnet, and again they will behave like the normal piece of metal. So in like this, even in the medical field also, by mistake, if any small piece of iron or something enters into the body, part of the eye or anything, they will use a small electromagnet to remove this and get it operated. Like this, we can find out many ways how electromagnets are used in our life. So before knowing the uses, you all should know what is an electromagnet. Again I repeat, electromagnet is an, what is it? An iron nail or an iron piece of iron wound with a insulated wire. It is wound means it is winding, we are tightly it is been done. See now how we are this winding, the electromagnet has its own strength, how much it can pull or how much work. So many iron fillings if you keep, it is able to pull only few iron fillings. So what can be done to increase the magnetic effect? So we can increase the number of turns, and also here one more cell also can be added. Once you have to increase the strength of the electric current you are going to give, and also this winding is very important. That should be done in one direction only. When you can make, always children will make and bring. Just you take iron nail, and if you have the insulated copper wire from your home, you start winding, but you should wind it in one direction only. If you do in two direction, and this will cancel each other, the current flow, and it won't act as an electromagnet. When you are trying to make an electromagnet, the iron piece or iron nail, and you should wind the copper wire in one direction, insulated copper wire. So that is only is going to behave as the electromagnet as long as you are going to supply the electric current. Yes, so how can we increase the magnetic strength here? By increasing the number of turns, and also by one way is by increasing the number of turns, and one way is by increasing one more cell. So this all you will be learning when you are going to the higher classes. By now you all should know what is an electromagnet and how you all can make your own electromagnet, and you can enjoy the playing with that, bringing the bar magnet near to that, or bringing the iron fillings or some clips near to that, and you can see how it is acting as a magnet. So as long as you are supplying the electric current. So electromagnets, as I told you, it is useful in many ways now. So now one important application is electromagnets are used in electric bell also. So electric bell, you know that in the school or many places we use the electric bell. So how does the electric bell work? Where is the electromagnet placed there? That's what we are going to learn further, children. Yes, children. So now we are learning about the applications where the electromagnets are worked. So one such device is the electric bell. So we will see how an electric bell works. Here is the circuit, children. This circuit will show you a simple circuit which shows what are the components in the electric bell. Here you can see there is an electromagnet. Electromagnet is there connected through a battery. Here you can see the battery, and here is a switch. We can keep it open till we first understand the components, and then you can see a screw here, children. There is a screw, and here one hammer like thing and a gong. See, gong and hammer is not a new thing for you. You can see manually when we a bell with a metallic bell, there will be a gong and there will be a hammer to strike it. Same way here also there will be a hammer and also a gong, children. And the screw will be attached to one metallic strip. This is one metallic strip again. See, it is close to it is near the electromagnet. There is no connection between these two. So again I repeat, what are there in the electric bell? You all know that battery and switch. So no need to explain what is a battery and how a switch will control. So very things which you have to remember is there will be an electromagnet. Electromagnet is nothing but two iron bars bound with some insulated wire which is going to act as an electromagnet. In the previous activity, how we took iron nail and we wound it with insulated copper wire. Same way here there are two iron bars with which is wound. Wounding means winded with the insulated wire which is going to act as an electromagnet. What is electromagnet? It will act as a magnet only when electricity is be given. Which is going to supply electricity? Here the battery is going to give it. Which is going to control, the switch will control. So now near to this there is a metallic strip. A thin strip made up of metal. And then upper part of the metallic strip we can see the hammer and there is a gong. Gong and hammer will not be in contact. So gong, and this is the gong, and there will be a hammer, and here there is a screw. The screw is there connected. A screw. So in the normal. So now we will. So this is the circuit. So now we will make the circuit complete. That is, we will make it as a closed circuit. So once this screw is in touch with this. So now see, everywhere connection, nowhere it is open. So switch is on, and you see everywhere the wires are everything connected. Switch is touching the screw is touching the metallic strip. So now current starts flowing. You all know that when current starts flowing here in this place, this setup, that is, it is going to act as an electromagnet. So once it becomes a magnet, what it will do? Nearby the previous activity, we had the iron fillings or some pins also can be kept out. Here this will start pulling. So this will start pulling. Once this part acts as an electromagnet, this will pull the metallic strip. So once this pulls the metallic strip, this hammer will hit the gong. This hammer will hit the gong, and we can hear the sound is produced. But once this moves, what will happen? The screw gets detached. So once get detached, it is becoming an open circuit. So now current will not flow. When current is not flowing, this will act as an electromagnet. So it won't attract. So once it stops attracting, it won't go this side. No, it will come. It will move towards that side and it will rest. So that time again it will touch the screw. Again the current starts flowing. It becomes as an electromagnet. It is pulling the hammer. Gong is strike. When it is getting pulled, it is getting detached from the screw. So this will, with a very quick succession, very fraction of time this happens, and repeatedly, and that is how the sound is produced. See, two parts are there. How it works? Two parts. First, you all should know what all are the components in this circuit. So first, everybody knows that battery and switch will be there. And what are the new things which you are going to learn from the electric bell? There will be an electromagnet. Yes, there will be electromagnet, which is going to act as an electromagnet, and metallic strip, hammer, gong, screw. Yes, see, screw and the metallic strip, whenever there is no connection between them, the circuit is not closed. Even though your switch is on, circuit is not closed and there will be no flow of current. First part. So we can take it as two parts. Children. First part, what is happening? Screw is in contact with metallic strip. So when the screw is contact, so we consider as two parts this working. When the screw is in contact, normal condition, the screw is in contact with the metallic strip, the complete circuit is complete, current starts flowing, and this will act as an electromagnet and will pull the metallic strip. For metallic magnetism, due to magnetism, it will pull the metallic strip. Once it is pulling the metallic strip, the hammer will strike the gong. Yes, so it is the first part. Second part, what happens? So as soon as it is getting pulled, it will get detached from the screw. So once there is no connection between the screw and the metallic strip, the circuit becomes incomplete and current will not flow. Yes, so current will not flow. But what will happen? Current, when it is not flowing, the electromagnet this part will stop working as a magnet, and so that it will stop pulling the metallic strip. Metallic strip will come into its original place. So by the time it is coming, again it will touch the screw. So two parts. First part is metallic screw is in contact with the metallic strip, and hammer striking. This is acting as electromagnet. Hammer striking the gong, and the sound will be produced. And as soon as the screw gets detached, so as this part starts moving towards the electromagnet, the connection between the screw and the hammer is getting removed. So this will, current will not flow. The screw is not in contact with the metallic strip. So in the middle, this also happens. So first the current will flow, and once it starts moving, it gets detached. Screw is not in contact with the metallic strip, so that there will be no flow of current. No flow of current. So when there is no flow of current, what will happen, children? This will not act as an electromagnet, so that this won't pull the metallic strip. Again, the third part is it will go and touch the screw. Again, the screw is in contact. Screw is in contact. So this will continue. This will not take long time. This is very fraction of time. This all will happen. Screw in contact, screw getting removed, again screw in coming in contact, and continuously the current is made to, within a short breaks, it is made to flow, and that will be heard as the sound from the electric bell. That is how the electric bell works. So once if you read, three parts are there, three different steps are there, how it works. So once again, when you read in your textbook, you have in your textbook, please take page number 161 and 68. You have this siren nail activity. This you can try, as I told you. If you have the things at home, you can try. An electric bell also can be tried, but now whether things are there or not, accordingly you can read. See this, and your circuit is not labeled, children. So you can label now. The gong you label, hammer. See hammer, how they are, once it is going and coming. So both happens. It will strike and not strike. So gong, hammer, electromagnet you all know, battery, switch you know, and the screw. The screw is in contact, not in contact, again in contact. That is how repeatedly this happens, and the current flows, and it acts as an electromagnet, pulling and hitting the gong. The hammer is hitting the gong, and that is how the sound is produced. This part you can read and try to understand. Once you read 2 to 3 times, you will be able to follow what is given, and you see and draw. You know, an A4 sheet paper, you write the topic as electric bell, see and draw, and now with this you can, I hope that you can label it, and you can keep as points, and you can write the step by step, you can write how it works. And also this is one very interesting activity. This you try to do. As usual, today's question we'll see. Children, there is a sixth question. See in page number 171. When the current is switched on through a wire, a compass needle kept nearby gets deflected from its north-south position. Explain. That was, I think I have given you last class. Hope you might have completed. Now seventh question, you see, will the compass needle show deflection when the switches in the circuit show? We see here, this is a open circuit, so it will not show. So that also you can think and you can answer. Now 10th question, you see, children. Do you think an electromagnet can be used for separating plastic bags from a garbage heap? Can electromagnet can remove the plastic bags? So plastic bags are non-magnetic substances, no? So they cannot attract. So that you can, only magnetic substances which will attract, will get attracted towards the magnet, that you can answer on your own. Now I hope we have completed almost all questions. So you read it again. An electric bell part you complete and keep it ready for the next class, children. So by this our electric current and its effects complete lesson is over. Heating effect, its applications, and magnetic effect and its applications, altogether we have covered it. So you complete the learning part and keep it then and there. If you learn, it will be not a problem for you. Again and again I am repeating. So today's work, only one question, 7th question, and one more very simple questions. 2 questions are there in 171 page number, that you try to answer. There only you can answer. And in an A4 sheet you draw the electric bell, label the parts, and also you label the components, and also you try to explain how it works, children. We'll meet in the next class. Thank you, children.
Electromagnet is any conductor such as a straight wire through which electric current is flowing is an electromagnet. That's because there's a magnetic field around it. However, we can make the magnet strong by wrapping the wire around a piece of iron, such as an iron nail. Even if the current is the same in both cases, this one will result in a stronger magnetic field. Now, there are some factors on which the strength of the electromagnet depends. The current flowing in the wire is one of them. If we increase the flow of the current in the wire, the strength of the magnetic field of this electromagnet will also increase. Is there any other way? Yes, there is. Another way to increase the strength of this magnetic field is by increasing the number of turns of the wire around the nail. More the number of turns, stronger the magnetic field will be. We will learn about these factors in much more detail in our higher grade. In this video, we will see a few applications of electromagnet. So where do we use them? You must have seen large machines used to lift up cars. They have an electromagnet in them. This electromagnet is so strong that it can lift the whole weight of the car. Electromagnets are also used to separate metal objects from a pile of junk. Now, what if I tell you that they are used in the fastest trains around the world? Yes, the Shanghai Maglev train is touted as the world's fastest train, and it works on the concept of electromagnetism. Let's understand the use of electromagnets in simple devices such as electric bells. Yes, most of the bells we see nowadays are electric bells. Here's a very simplistic diagram of an electric bell. This is the inner structure of the bell. Let me first tell you the names of the basic components. This is a push switch, which is nothing but the switch we press when we ring the bell. This is a coil of wire wound around an iron piece. There could be two coils of wire wound around an iron piece as well. Remember, we've just drawn a simplistic version of the actual circuit. So it will act as an electromagnet when the electric current flows through the circuit. This is a battery and this is a striker which strikes this gong. That's when we hear the sound. So we can see that this is a circuit that can be formed. It's not complete. Why is it not complete? Well, we haven't pressed the switch yet. When we push the button, the circuit gets completed and the current flows from the positive to the negative terminal. But when the current flows through the coil, it becomes an electromagnet. This electromagnet then attracts this soft iron towards it. And in the process, the striker strikes the gong and the sound is produced. But notice what happens when the striker hits the gong. As soon as the soft iron is shifted away from its original spot, the circuit breaks. It no longer connects this wire with the terminal of the battery. And when the circuit breaks, the current stops flowing. So this electromagnet gets demagnetized, after which the soft iron goes back to its start position. This process will continue until the switch is open again. As soon as we release the push button, the circuit breaks and the bell stops ringing.